Hello, everyone. Good morning. Thank you for coming to this presentation. So, Unlocking the Power of Big Data, Analytics and AI, the title of the presentation. First of all, let me introduce myself. My name is Konstantinos Megalokonomos. I am part of the Smart Data team at Cognitive. And as the name implies, we do all things data. We're engaged in projects that have to do with analytics, building lakehouses, chatbots, recommendation systems. We do a lot of data quality and search engines. So through this presentation, I'm going to focus on some of the things we have built regarding these areas. And to do so, I will use a case study, specifically Payzy by Cosmote. And to give you some context, Payzy by Cosmote is a modern holistic digital solution. It allows users to cover everyday purchases and bill payments. They can carry out transactions with friends, family, and they can do so, all these things, through their mobile phone, through a mobile app, and they can do so securely, easily, and quickly. Some of the main features of this mobile application, and it makes sense to tell you about this in order to understand what we're going to talk about in terms of big data, analytics, and AI, are, of course, the functionality that I already said about making purchases and bill payments. It's the chat and play feature, where users can send money to other users as easily as sending a message through a chat. So just press by the press of a button. Creating Split It, which is creating groups where you add users and split expenses between the users, either in a predefined way or equally. It also offers piggies, ways to collect money, either by collecting change or creating specific scheduled transfers to the piggy, and of course cashbacks. All these features, how do they relate to big data, analytics, and AI? So we have some modules and solutions built on the back of this mobile application, and these are the areas that I'm also going to cover in this application, these specific 5 areas. So it's a recommendation engine. We have built a search engine, a chatbot, Blue Lake, how we call our end-to-end analytics platform, and an automated label extraction mechanism for creating keywords from articles and documents. So these are the 5 areas I'm going to focus on. And what is behind these 5 areas? What technologies? Some of these might seem familiar to you if you're into big data and analytics. So it's Elasticsearch, a NoSQL database. Spark we use as an analytics engine. Neo4j it's a graph database. We use it in our recommendation system. Visualization tools like Apache Superset, BI tools like Apache Superset or Kibana. An analytics database we use it a lot for streaming analytics, Druid. Kafka, of course, a framework for creating chatbots, Raza. Some other databases, Payzy for natural language processing, TensorFlow for training our models. We use some pre-trained models like BERT, Google BERT. Then we have Redis. We use it mainly for caching. Another NoSQL database, MongoDB, and we also use Apache Airflow for orchestrating all our ETL and data pipeline needs in the data lakehouse. So, zooming out of all these technologies, now that you know what's on the back, I would like to go one by one into these areas and give you some insight on what and how we have built it. So first of all, we have the chatbot. The chatbot here acts as a conversational assistant, a support agent. So it uses natural language understanding We have built several NLP modules that I will talk to you about in a second in the next slides in order to make understanding the language better and more efficiently. It is trained to solve problems and answer frequently asked questions. And it also provides an automated approach to opening and closing support tickets. And of course, when opening tickets, it also provides a way of gathering information so that when the ticket needs to be resolved, it can do so quickly and more efficiently. All this, of course, in a friendly, personalized interaction, and we also have built-in follow-up and next best actions. How we do all this? We use, as I said in the previous slide, the RASA framework. RASA framework is an open source tool. It's written in Python. You can use it to train conversational models. It understands user input, and it generates responses. You can maintain context over a series of interactions, and it's comprised of two main components. RASA NLU is the first component that is basically used to understand the message of the user, and RASA Core, which is the component that has to do with dialogue management and decide how to generate responses. Building a RASA pipeline is as easy as editing a YAML file. So the basic process of understanding an input message that comes from the user is going through a preprocessor, where some pre-processing tasks may be created on top of that message. Then the message goes through a tokenizer. Tokenizer breaks the input message into tokens. The tokens are then vectorized, so you create vectors out of them. Then some features are created from these vectors, and they are fed into the transformer in order to classify the message. Of course, as I said, this is all open source, so we can create very easily our own pipelines, custom pipelines. We can even create and edit our own components. So taking it out of the box tokenizer, vectorizer, it's very easy to take it as a template and build your own tokenizer or vectorizer. And it's very easy to integrate with third-party models. So as an example here, it's very easy. It's just taking this YAML file and configuring it in a way to, here I have actually used the BERT language pre-trained model, and I'm including it in my pipeline. So I use Hugging Face transformers. In the first line, I call which model I would like to use as a pre-trained model. So I use BERT and which specific weights I want to have. And then this model goes through, the message goes through the respective language model tokenizer, the featureizer, and then the classifier, which is the transformer that classifies the message. As easily as this config file, other pre-trained models can be used. So I said BERT. There's also GPT, which is the talk of the town lately, and I had to put it in my presentation. ExcelNet, DistillBERT, Roberta, a lot more. And of course, one we use a lot, I have included here, is Byte2Pair, another pre-trained language model. So I said that this all goes into the final classifier to decide what the user's intent is, what he wants to say. To do so, RASA provides the diet classifier. It's a very diverse classifier. It has actually two jobs. Both at the same time to understand what the intent of the user is, and also extract some entities. So this is why the name is dual intent and entity transformer. This is what diet means. So for example, I have an input message. I would like to attend Devox Athens. This goes through preprocessing, tokenization, vectorization, feature created, and then fed into diet. And the diet will come up with these two outputs, the intent, which is I want to attend something, and an entity, which is Devox Athens, what it is that I want to attend. As I said, we have also built some NLP modules on top and several other and some integrations. The first module has to do with offensive language, so the bot understands offensive language and can respond accordingly. And then there is a chit-chat module where the bot is trained to engage in chit-chat with the end user. And another module is the Greek NLP. This is something we have worked on a lot. Is a way to transform the message in a way so that the natural language understanding modules can understand it better. And we want to understand Greeklish, which is the first thing we wanted to tackle. And it's Greeklish, for those that are not Greek, is when users write Greek, but using English characters. Okay, so it's very difficult, if non-existent, to find such a pre-trained model. We have to understand using other techniques and algorithms what the user would like to say. So here he says, I would like to make, I couldn't make a transfer of money, and there is a support article that the bot goes back to the knowledge base, finds an article, understands the message, and returns the correct article. And the final thing I wanted to talk to you about modules is that we have integrated the bot with knowledge base. So this is used in order to retrieve answers to basic questions, and it works as an FAQ. And talking about integrations, one thing about Rasa, since we're talking about Rasa, is that as it's open source, it's very easy to create integrations and do custom-like things instead of having out-of-the-box chatbots. So our chatbot is integrated with core banking, with a customer profile, with ticketing, with a knowledge base that I already explained. And so when the user goes inside the chatbot and he wants to speak and create and ask his question, we already know who the customer is, what assets does he have, what open tickets he may have, and if there are any FAQs that could answer his questions. And here I have created some demos for you. I hope they work. So yes, in the first demo, I go inside the bot, and the user goes inside the bot, and first of all, he says hello, engages in chit-chat, the chatbot replies, and then he asks a question, and it does so in Greeklish, so a normal Greek language model wouldn't understand what he was saying, but we use the phonetization and fuzzy rules to understand the message, and actually asks he would like to freeze his card, so the bot understands the message. All this is from the production, from what is live, you can also test it, and goes back to the knowledge base and returns an article that is relevant to what he asked. And the second example that I wanted to show the integration with assets. Actually, as I said, users can create piggies, so which is ways of collecting money. So the user can go inside the chatbot and ask about a specific functionality and select piggies. As soon as it does that, the chatbot, through integration, knows what piggies I have created as a user. For example, a gift for my daughter, or some money to gather for my summer vacation, etc. And it goes on to ask me, okay, which one of these piggies would you like help with? And it goes on to manage the conversation and create a ticket or answer, if possible, without even going further. All this is really nice, but if you are into chatbots, you really know that actual testing and fine-tuning happens when we go live, because it's very difficult, if not impossible, to mimic how end users will actually use this chatbot without going live. So it's really important to have reporting mechanisms for all this. What we do is we have Rasa, the chatbot framework, events are recorded, they are then sent to a topic on Kafka, the messaging platform we use. Then maybe a Kafka streamer will do some transformations, and the data will be then stored to Elasticsearch. And then, as I said, we use for a visualization tool Superset. All these are open source tools. So you can see visualizations of how these bot flows go on. Two main visualizations we have created, and this might be of value to anyone that wants to report on chatbots is the Sankey diagram. One of them is the Sankey diagram. Here, the width of the line is actually the amount of people that choose this path through a conversation flow. And the vertical lines are the steps. So most go through from A through S and then to S3. This is a way of very quickly visualizing such a bot flow. Another way to do that is using the sunburst diagram. These are homocentric circles. These are all come out with a superset, okay, so which is available for everyone to download. And we have homocentric circles. The inner circle is the first step of the flow, and as we go outside, the other circles have the next steps, and we can see again how much part of the conversation is for each path. All this is really important because, as I said, we want to evaluate and optimize our bot flows. We need to identify wrong discussion paths, optimize our articles, and at the end of the day, fine-tune our training models for our models. So I think the benefits are pretty clear, but the chatbot will reduce costs and support back-office tasks. It creates personalized experiences and builds relationships, and it's always available, which is really important when you have support, to have something that an agent that's 24/7 there. Of course, we can also upsell and cross-sell. Second area, jumping out of the chatbot, I go to the recommendations system. Our recommendations engine is built on a graph database Neo4j. So what we do is we keep a record inside Neo4j of connections that are created through the customer's journey. So when the customer syncs his contacts from the application, these are recorded, they are kept, the connections are kept inside Neo4j. When he engages in chats with other users, again, these are inside the Neo4j, split bill connections. So when the time comes to create a new chat, let's say I want to talk to someone, create a new chat, or I want to create a new splitted account where I will create a group and I will split the money between them. The application comes back and the recommendation engine will run an algorithm in all these connections and data we have collected through Neo4j, and it will provide some recommendations of who to add in this group. Of course, all this is really strictly restricted by user consents and privacy. And this, on the next slide, this is a screenshot from Neo4j for those who have not engaged in a project with Neo4j. And so what I want to say is that, of course, all these algorithms that we have built on top of these connections that are kept in Neo4j have to go through exclusions. We have to exclude blocked users, deleted users, users that have different KYC level that shouldn't be contacted, or those users that have their searchability disabled. Also, we have built some nice stuff like type ahead. We actually use 3 letters. And one other nice functionality is that when you sync your contacts and a user of the mobile application joins the application, you are notified through a notification system that your friend from that you have synced has joined the app. You can write to him or add him to your groups. Another area after this, the recommendation engine that I would like to cover is the search engine. So our search engine is based on Elasticsearch. It's mainly integrated with Chatbot. Elasticsearch, for those that don't know, is a NoSQL database that's oriented. It has great mechanisms for natural language processing. Okay, and the way you use it is actually the chatbot uses the search algorithm to go back in the knowledge base and retrieve articles. And also we have built an administration tool that we can use to either go through the knowledge base and add edit articles or manage the weights of the search engine. How does this work? So in Elasticsearch, we have stored the title of the article, of the frequently asked question. We have stored the content and maybe some keywords. And then an algorithm is built on top of these three, where we have weights. We search in all three. We search also title, also content, and keywords. But we add weights in the algorithm that decides if a match is made or not. And as I said, through the admin tool, we can add, edit, delete articles, or control these weights of the algorithm, an administrator. How does the NLP work in this search engine? So what we do is we do some basic normalization of the query. We do, as we saw in the chatbot, some Greek list detection and understanding. We use stop words. Those that don't know Elasticsearch or what stop words are words that have no particular meaning and will provide nothing valuable to our query, so we can exclude them. For example, articles. Synonyms, so we can search for a word that doesn't exist in our documents, but a synonym exists there. We can handle typos, misspellings. We do phonetics analysis. We can do partial matching. And also, we use lemmatization and stemming. Lemmatization and stemming is searching with the lemma of the word. So if you have a word that has the same lemma, it will be identified in the knowledge base. How we do that, and this is of value from the technical side. We do all normalization. Actually, you can do it in many ways, but in our project, we do it in the pre-processing phase. Greek list detection and understanding, we do that by we have created phonetization algorithms. So what we do is we give more value to how the word sounds than how it is written. And usually, when users write in Greek list, that's what they want to do. They use English characters to make them sound like how it would sound in Greek. So using the phonetization algorithm, we tackle the Greek list problem. We use stop words and synonyms is quite out of the box for Elasticsearch, so it's a matter of setting it up in the settings. For typos, we use a feature of Elasticsearch that is fuzzy searching, and you can also add parameters. Partial matching, we use n-grams. Partial matching means actually matching substrings. And then lemmatization and stemming that I talked before, it can easily be set up through an analyzer in Elasticsearch or using plugins, etc. What is important to note here is that, and I would like to put some attention, is that if you put all these 8 stuff at the same time and try to make a search, it might not go that well, and you might have poor results. It needs careful tuning at every time you create the query, which ones of these you will use in your query, and to what amount. Putting all of this at the same time will not create better results. I have here some examples again. So the user goes inside. As I said, the chatbot is the main user of the search engine. So we go inside the chatbot, and I create a question like I would like to ask more regarding money transfers. I think that's what I wrote. Okay, and then this will go. The chatbot will understand that this is a message that I want to answer. The user wants to ask a question. It will take it. It will send it to the search engine, which will contact the knowledge base and come back with 2 articles. And then I will choose which one is more relevant to my question, and then the bot will take over, as I said in the previous section. And again, in the second example, here I wanted to show again the Greek list mode. So I will the user writes something in Greek list, and the bot will understand the message that it is a question, will send it to the search, will contact the search engine through an action, the engine will contact the knowledge base, and come back with a relevant article. So here he asks if there is a fee when you do a top-up on your card. The search engine comes back with a relevant article that has to do with fees on top-ups, and the user can read it and then give back feedback to the bot whether he likes or not, whether he is satisfied with the answer or not. Having talked about the search engine, the next topic I wanted to cover was the keyword extraction, and it's very relevant to the search engine because these keywords are used by the search engine. So what is keyword extraction? We wanted to automate the process of creating keywords from specific documents. And this would make the whole searching even better and more efficient. One way is, of course, an agent to go down and write keywords and read the article, etc. But we want to automate this process, and how we do it is we use statistical methods, and we also used pre-trained language models. Specifically here I have an example of BERT. We do create 3-word phrases when searching for keywords, not just a specific word. We do so both for the content and the title. And as I said before, these are weights are put on these keywords, and the whole algorithms for searching is created. One more last thing important about this keyword extraction is that we do some NLP analysis. Specifically, we use Payzy, and we do so because we do a part of speech, and we want to exclude words from becoming keywords that are not relevant to what that wouldn't provide value to what we do. Usually, for example, we keep verbs, we keep adjectives, these kinds of words as keywords. How does this work? How do you create such an algorithm for creating keywords? So we have a document, our document. We create from the left side an embedding, which is a vector of what we think this document maps to. So we do a document embedding, and from the right side we take turn into creating word and phrase embeddings. These two vectors that are compared through cosine similarity algorithms, and the final labels are created. What we want to do is the word embedding that we have created be as close as possible to the document embedding. That means that it's more relevant to it, to the representation of the document. It's not that simple because, as I saw here, what we've done is we don't rely on one model. We do use many statistical algorithms, and we do use many pre-trained language models. And then we create groups of keywords for each algorithm. So we have labels for algorithm 1, labels from algorithm 2, etc. And then labels from pre-trained model 1, and goes on. And then on the final step, we take something like a highest common factor. It's not exactly that, but we try to see, okay, we did all this, we try to tackle the problems from so many sides. Which keywords do seem to be the most relevant in all the cases? So we do this highest common factor. And here is a quick example. So I take a document. The first algorithm creates these 3 keywords, great, keyword, and extraction. The second algorithm gives names, keyword, extraction, and so on. And then I take the highest common factor. So my keywords would be keyword and extraction. Final area I would like to talk about in this presentation is the Blue Lake. Blue Lake is an end-to-end analytics platform we are building. It's a data lakehouse, essentially, with some business intelligence tools. It covers batch and streaming analytics. It's used both for reporting and monitoring and alerting. We do analytics on KYC, operational analytics, demographics, system analytics, and also we have we are setting up, because all this is a work in progress, some data quality monitoring tools. The basic development areas in this area of the project is we need to ingest data, so we need to find all the sources and bring all the data into a data lake. We have to build ETL and data pipelines to take the data, transform them, combine them, and enrich them into areas of interest. We have then the part of storing the outcome in an analytics database. As I said, this is probably most of the times Druid, Apache Druid, and make them available for analytics, both for batch and streaming. And at the end of the day is developing the business intelligence tool to query the data and make visualizations and dashboards. So I think of most interest would be the streaming analytics. So what we do is we have Kafka with our topics where we collect data, then Spark is used to process the data and transform them, and then put them some new Kafka topics that are used by reporting, our reporting enriched, transformed topics. Then there is a straight connector to Druid, and Druid can ingest this data in real time, and then Superset can handle and make these visualizations be real time. The whole architecture, so this is very simplified, because it would take hours here to show the whole thing, but we have our sources, mainly MySQL, Mongo, Elastic, and Kafka. We use the processing engine, which is Spark. We go into Druid, which is our analytics database, and then there's the visualization tool, which is Superset. All this is orchestrated by Apache Airflow. Okay, and the purple line is the streaming path, and the other paths are the batch paths. So as I said, we do reporting, which is the reports we all know from the dashboards, and they support creating filters, etc. And they have many graph types, pie charts, bar charts, and all this. We do this with Superset, and we do this monitoring also with Superset, which is as simple as going to a report you have created and setting an auto-refresh interval, so the graph auto-refreshes itself. And since the data behind the visualization is also in real time, as I showed in the previous slide, through Kafka, maybe if we want to do a transformation, Spark and then Druid. Also the visualizations are real time. And then for alerting, what Superset offers is a couple of ways to do alerting, but one way is to integrate it with Slack. So this is, again, very easy. It's as simple as setting up a Superset config file and setting up the integration and tell it to use Slack and put some tokens, and then going on the other side with Slack and creating a new app in the Slack workspace. Finally, one thing about the data lake is we are building, as we go, some data quality tools, monitoring tools. We count unique values, nulls, patterns, masks, ranges for every field, for every table. We do frequency analysis, min, max, lengths, and over time. We need to create all this and in time move towards the data management platform, because it's very important for this end-to-end analytics to be clean. And this, as the last slide. So why Blue Lake? Blue Lake is actually the clearest lake in the world. It's in New Zealand. We used this name just to remind ourselves that we need to keep this data lake not becoming a swamp and build methodologies and build the mechanisms to keep it that way. That's what I said about data quality tools. And to go back full circle to my initial, to the title of this presentation. So unlocking the power of big data, analytics, and AI. And what we have done here is through these 5 areas that I showed you, reporting, the data lakehouse, recommendation engine, a chatbot, the keyword extraction. We have built an ecosystem that is all backed by these big data and AI tools that we have used. And all this goes back to create a great user experience and satisfaction. It removes workload from support. It provides fast and streaming analytics to the insights for quick decision making. And at the end of the day, it lays down the foundation for making data-driven actions in the future. So thank you very much. If you would like, thank you. So I would be more than happy to answer any question you may have now, or if someone wants to find me after in the breaks, I'm available for everyone. And if you want to know more about the project or how it works or the team, please ask. And yes, so someone would like to ask something? Okay.
Is the performance of the bot equal to when I write in Greek and when I write in Greekish, or is there a difference there?
Nice question. But the way we have set it up is we use the same algorithms for phonetization for Greeklish, also for Greek. So the results should be the same at the end of the day. Yes. That's the quick answer. Yes?
How easily it can be implemented in other languages?
Okay, so our colleague asked how easy it is to do an implementation of this chatbot in another language other than Greek. To tell you the truth, if we did it in Greek, it should be as easy as it was in Greek, because there is not a lot of pre-trained modules. There's not a lot of material out there regarding Greek. And Greek is actually a very, because it has a different lettering and different alphabet, it was quite complex. But it's built in a way that the pipeline that I showed you in the beginning is very easy to configure. And if there are ready-made models available for your language, for example, BERT or other pre-trained models, it's as easy as going there instead of telling use the Greek BERT model, then use the English or the French or any other model. And how you train it is you provide examples, training examples. So if you provide training examples in your language, it should be no problem. Yes?
You said you're using natural language processing to produce answers, but the answers are actually articles. Are you planning, or is it possible to produce using natural language generation to produce actual answers?
Yes. I will say the question again for everyone who didn't understand. So our colleague asked whether what we do in this presentation is we take a question and we understand that it is a question, and then if we understand it's a question in the chatbot, we forward it to the knowledge base. So what you asked is whether instead of searching a ready-made article, we could use generative natural language and create an answer from a pre-trained large language model, which is, again, the talk of the town. We have ChatGPT right now. So Rasa is the framework we use. Is an open source tool. You can do any integration you like. So it's very easy to create an action that when you receive the question, instead of forwarding it to our search engine in the articles, you hit another endpoint that has for example, ChatGPT. And it's as simple as hitting that endpoint, getting the answer, and providing it to the user. Also, there are tools that Rasa has to also create your own generative modeling, include your own generative models, not just integration with a third party. So yes, you can do that as well. And we do it in other parts of the project that I haven't shown in this presentation. Yes?
Is this infra deployed on cloud? And if yes, which provider and which managed service do you use?
Okay, no, so it's not. It's in-house. All on-premise, not in-house, on-premise. Yes?
Did you test your model for, in terms of security or for leaking private sensitive information? So if a malicious user starts chatting with it and extracting personal information?
Yes, of course. We have. There are specific methodologies and teams that before anything is released, they go on and test and provide reports on security. It's one of the reasons this is all on-premise is that we want to create the data. The companies wanted the data to be here. the mechanisms are also done by external teams, not by us. So there are reports, security reports, and all this is then tackled if there are findings before anything goes live. Nothing can go live unless these reports are passed. We have time? Okay, we can talk on the break. Because I think our time is up. Anyone who would like to talk something more, I'm available. Thank you very much.